Dear students, once again I welcome you to the solution of assignment 3. You have gone through the various concepts related to conditional probability and statistical distributions in week 3. The assignment 3 was given to strengthen your understanding and learning on these issues. There were total 25 questions, all were of multiple choice and only one answer was correct. Question 1. What is the probability that a person scored A if he or she is a female? Use the following data. Male scored A 45, scored less than A 70, female scored A 80 and scored less than A 55. Option A 0.59, option B 0.18, option C 0.64 and option D 0.11. The solution to this question, the correct answer is A 0.59. Let us see how we can reach to this answer. If we compute the probability that a person is male, then it is 115 divided by 250. You can see in the table that I have done the totaling for row and column both, which is equivalent to 0.46. Probability that person is female, PF, is 135 divided by 250, which is 0.54. Probability that a person is female and scored A, which is P probability F intersection A, equivalent to 80 divided by 250, which is 0.32. Now, if you look at the question, probability that a person scored A and if he or she is female, then probability A given that the person is female, then probability F intersection A divided by probability F, which is female, equivalent to 0.32 divided by 0.54 equal to 0.59. Question 2. Which statement is correct regarding conditional probability between two events? Let us say event A and B. Probability of event A is happening and probability of event B is happening. Option B, probability of event A is happening or probability of event B is happening. Option C, probability of event A is happening that event B has happened. And option D, probability of event A is happening when event B is not happening. The correct answer is C, probability of A given B can be expressed as the conditional probability of event A happening given that the event B has happened. So, probability of A given B is P A by B equal to probability A intersection B divided by probability of B. Question number 3. What is the condition for mutually exclusive events? Probability, option A, probability A union B is equal to PA plus PB minus PA intersection B. Probability A union B is equal to PA plus PB. Probability A intersection B is PA into PB and probability A union B is equal to PA minus PB. The solution is answer B is correct. The reason, for mutually exclusive events, the sum of the probability is 1 and probability of A intersection B is 0. I can just remind you that mutually exclusive events cannot happen at the same time. For example, when tossing a coin, the result can either be heads or tails but cannot be both. Similar way, events are independent. If the occurrence of one event does not influence and is not influenced by the occurrence of the other event. Question 4. In a drug test, the following data is given. Event A is that a patient is a woman and event B is that the drug is failed. Which of the following statement is true? You are given the tabulation that the drug test is success, women 400, failure 2000, men 2000 and the failure is for men is 400. Event A is independent of event B. B. Event A is not independent of event B. C. Event A and B are mutually exclusive events, and D. Event A and B are not mutually exclusive events. The correct answer is B. I would also like to present the proof. For independent events, the expression or formula is PA into PB, which is equal to probability A intersection B. Here PA is 2400 divided by 4800 and it is equal to 0.5. Probability B equal to 2400 divided by 4800 equal to 0.5. So if I take the multiplication PA into PB, it is 0.25. Actually, if I see the data given in the problem, then probability A intersection B is 2000 divided by 4800 equal to 0.41, and these two 0.25 and 0.41 are not matching, and hence the answer B, that is event A is not independent of event B, is correct. Question 5. A medical test kit is used to check cancer which is faulty in a hospital. If the test is positive, it is not always true that the person has cancer. 94% chances are that the test is positive and the person has cancer. 5% chances are the test is positive and the person is healthy. We know that cancer is rare, and in the general population of New Delhi, probability of cancer is 0.1%. If a person is randomly selected and his test is positive, what is the chance that he has really cancer? The option A is 0.0175, B 0.0165, C 0.0195, D 0.0185. The solution is interesting. The correct answer is D, 0.0185. If you look at the solution in detail, then probability that the test is positive and the person has a cancer, that is probability positive given C is equal to 0.94. Probability that the person has a cancer, that is PC, is equal to 0.001. Probability that the test is positive and person has not cancer, that is P positive given C complementary bar, equal to 0.05. Probability that the person is healthy is P C bar is 0.999. Probability that the test is positive and the person has cancer is probability that the test is positive, intersection C stands for cancer, can be expressed as probability positive given C into PC, which is PC given positive into P positive. Probability that the test is positive can be given as P positive is equal to P positive given C into PC plus P positive given C bar into PC bar. So we are interested in finding the probability that the person has really cancer, P probability P C given positive. So it is equal to P positive C into PC divided by P positive, and if I substitute the values, then 0.94 into 0.001 divided by 0.94 into 0.001 plus 0.05 into 0.999, which is equal to 0.0185, and hence answer D is correct. Question 6. In a drug test, the following data okay. Question 6. In a drug test, the following data is given, and once again I am raising a question that what is the probability that a person is a man and the test is success. So, success is 800 for women, for men it is 1200, failure it is 1200, and men failure is 800. So, you are given 4 options 0.5, 0.2, 0.3 and 0.4. The correct answer is very simple, probability A intersection B, which is 1200 divided by 4000 equal to 0.3, and hence answer C is correct. Question 7. Events A and B are independent if and only if probability A by B is equal to PA, if and only if probability A by B is equal to probability A intersection B divided by probability B, if and only if probability A by B is equal to probability A intersection B divided by probability A, if and only if probability A by B is equal to probability A union B divided by probability A. The answer is A. Events A and B are independent if and only if probability A by B is PA. So, happening of A or B does not affect the happening of the either of the event, and hence the option A is the correct answer. Question 8. If 2 events are independent, then which of the following holds good? Option A, probability A intersection B is equal to probability A union B minus PA plus PB. Probability A intersection B is equal to probability A union B minus PA minus PB. Probability A intersection B is equal to PA into PB, and probability A intersection B is equal to PA plus PB. So, answer is C, and the solution is probability A by B is PA, probability A by B is equal to P intersection B divided by PB. If I rearrange the terms, then probability A given B into PB is equal to P intersection B, and PA into PB is equal to PA intersection B. Question 9. A coin is tossed twice. In event A, there are 2 heads as outcome. In event B, there are 1 head and 1 tail, and tail and head as outcome. What is the probability that the both events happen jointly? So, you have option A 0.00, option B 0.25, option C 0.5, and option D 1. The correct answer to question 9 is A 0.00. The reason is probability A intersection B is 0, as there is nothing common in both the events, so probability is 0. Question 10. If a coin is tossed 3 times, then what is the probability that you observe exactly 1 head? Option A 0.125, option B 0.250, option C 0.875, and option D 0.375. The correct answer is D 0.375, and you can see the solution that probability of having 1 head is equal to probability that you can have HTT union H, THT union TTH equal to probability of HTT plus probability of THT plus probability of TTH equal to 1 by 8 plus 1 by 8 plus 1 by 8 equal to 3 by 8, and hence the answer is 0.375 D. Question 11. For 3 events A, B and C, we know that A and C are independent, B and C are independent, A and B are disjoint. probability A union B is given 2 by 3, B union C is given 3 by 4, and probability of A union B union C is given 11 by 12. What is the probability of event B? You have 4 options, 2 by 3, 1 by 2, 1 by 3 and 1 by 4. The solution is explained here. The correct answer is B, 1 by 2. In order to simplify and understand the given problem better, we can draw the Venn diagram. You can see that right hand side there is circle A, circle B and there is circle C. There is A intersection C and B intersection C, but if you look at the problem, A and B are disjoint. So, we can say that probability of A union C is given as A plus C minus AC equal to 2 by 3. Probability of B union C is given as B plus C minus BC, which is equal to 3 by 4. And probability of A union B union C can be given as A plus B plus C minus AC minus BC, which is equivalent to 11 by 12. So, if we subtract the third equation from the sum of the first and second equation, we immediately obtain C is equal to 1 by 2 and hence A is equal to 1 by 3 and B is equal to 1 by 2. So, the correct answer is 1 by 2, answer B. Question 12. You toss a coin repeatedly until you observe the first tail, at which point you stop. Let x be the total number of coin tosses. Find probability x is equal to 5. Option A 1 by 8, B 1 by 16, C 1 by 32 and D 1 by 64. The correct answer to question 12 is C, which is 1 by 32. We can see the solution, which is very simple. The outcome of the random experiment is x. The goal is to find PA is equal to P5, but what does x is equal to 5 means? This means the first 4 coin tosses results in heads and the fifth one result in tails. Thus, the problem is to find the probability of the sequence H, 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 T when tossing a coin 5 times. Note that H, 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 T is a shorthand of the event, and the first coin toss results in heads and the second coin toss results in heads, and similarly third and fourth coin results in heads and fifth results in tails. Since all the coin tosses are independent, we can immediately write P H H H T is equal to probability of getting head multiplied by probability of getting head, similarly multiplied by probability of head and multiplied by probability of tail, which is equal to 1 by 2 into 1 by 2 into 1 by 2 into 1 by 2 into 1 by 2, which is 1 by 32. Question 13. What is the probability that people will bring umbrella when they see that grass is wet? Based on Bayes rule, probability that it rained is 80%. Use the following data. You are given the tabulated data. The first table on left side, you can see that probability that grass is wet and it has rained, given that it has rained, and there are 2 options. W, it means the grass is wet, minus W, it means grass is not wet. R means there is a rain, minus R means there is no rain. Similar way you can interpret the table given on right side. It states probability U given R, it means U stands for that people will bring the umbrella, minus U means people will not bring the umbrella, R means there is a rain, minus R there is no rain. So, there are 4 options: A 0.953, B 0.875, C 0.792 and D 0.548. The correct answer is B 0.875. Let us look at the solution. What is the probability that people will bring umbrella when there is a wet grass is wet given there is a rain. So, you can find it as probability u given r into probability w grass is wet given r, which is equal to 0.9 into 0.7, 0.63. Similar way you can evaluate the option that people will bring the umbrella when the grass is wet given that there is no rain. So, it can be expressed as probability uw given minus r equal to probability u given minus r into probability w given minus r equal to 0.2 into 0.4, which is equal to 0.08. Now, Pw, probability that the grass is wet, can be expressed as probability w given r into Pr plus probability w given minus r means there is no rain into probability minus r means there is no rain, equal to 0.7 into 0.8 plus 0.4 into 0.2 equal to 0.64. Probability P minus W means the grass is not wet can be given as a complementary event 1 minus Pw equal to 0.36. Now, probability Uw means people will bring the umbrella when there is a grass is wet can be expressed as Puw equal to Puw given r into Pr plus Puw given minus r into P probability minus r equal to 0.61. Same way, probability u given w is probability uw divided by Pw, which is 0.875. So, the final expression I have substituted the values found previously and it comes out to be 0.875. So, the answer B is correct. Question 14. Let us consider in a pot there are R red balls and B black balls and total balls is n. A sample of n which is consisting of B blocks, black balls and R red balls is taken out from the pot. What is the probability that there being B block balls in the sample of n? Now, in this particular question, you should understand that the process which is described here follows which particular distribution. If you can understand this, then immediately you can figure out that what is the probability distribution function for that particular event process and what could be the right option. So, you are given 4 options A, B, C, D available on the screen and you can see that this process follows the hypergeometric distribution and the expression or formula for hypergeometric distribution is Pb by n equal to BCB into n minus BC n minus B divided by NCN. Question 15. Coefficient of variation is option A sigma by mu, option B mu by sigma, option C sigma into mu and option D mu plus sigma. As per standard convention, sigma stands for standard deviation and mu stands for mean. So, the correct answer is A. By definition, it is sigma by mu, which is coefficient of variation. Question 16. A large group of students took a test in physics and the final grades have a mean of 70 and a standard deviation of 10. If we can approximate the distribution of these grades by a normal distribution, what percent of the students scored higher than 80? So, in the lecture you have gone through the normal distribution and how to find the probability using the standard normal table. You can make use of that knowledge and find out the probability here. You have 4 options A, B, C and D. Let us look at the answer. The correct answer is B, which is 15.87%. If we see the solution, then for a standard normal distribution given x is equal to 80 and z is equal to 1, I can use the expression z is equal to x minus mu by sigma and area to the right. higher than z is equal to 1 is equal to 0.1586, which is equal to 15.87%, and hence this is the probability that the student has scored higher than 80. Question 17. The distribution of sample average approaches the normal distribution is A. The central limit theorem, B. Bayes rule, C. The Poisson theorem, and D. Normal distribution rule. This is an important question to be remembered. If you see the solution, our correct answer is A. The central limit theorem, and the central limit theorem clearly states that if y1, y2, yn is a sequence of NIID independent identically distributed random variables with expectation of yi is equal to mu I and variance of yi is equal to sigma I square, both finite, and x is equal to y1 plus y2 plus up to yn, then z can be expressed as z is equal to x minus sigma I is equal to 1 to n mu I square root of sigma I is equal to 1 to n sigma I square, and this distribution of the sample average approaches the normal distribution. Question 18. Let us consider a situation in which a sample size is given and mean is given. Variance and standard deviation are unknown. Instead of variance, sample standard deviation is known with degree of freedom. In this situation, which distribution suits the most? Option A, normal distribution, option B, beta distribution, option C, t distribution, and option D, gamma distribution. The correct answer is C, t distribution. T distribution basically considers the degree of freedom, which can be expressed as y minus mu by s. So, in normal distribution, if you see z is equal to y minus mu by sigma, and it does not give any idea about the degree of freedom. So, looking to the data available for this situation, t distribution is the best suited one. Question 19. In a hospital, 70% of patients are dying of a disease. If on a certain day 8 patients got admitted in the hospital for that disease, what are the chances of 5 to survive? Option A, 0.051, B, 0.042, C, 0.039, and D, 0.047. If we look at the solution, the correct answer is D, 0.047. You can look at the data and understand that it follows a binomial distribution, and you can make use of the expression of the binomial distribution and substitute the necessary values. Here, for Px is equal to 5 patients, 5C8 into 0.3 raised to 5 into 0.7 raised to 3 is the expression of binomial distribution. When I expand this, it will give me the probability, which is 0.046675 can be approximated as 0.047. Question 20. What is the basic difference between binomial distribution and Poisson distributions? A, in Poisson's distribution you need the size of the sample. B, in binomial distribution you need the size of the sample. C, in Poisson's distribution you need variance. D, in binomial distribution you need variance. The correct answer is B. If you see the binomial distribution, xcn into px into q n minus x. If you look at the Poisson distribution, pk is equal to lambda raised to k into e raised to minus lambda divided by k factorial. So, in Poisson distribution there is no sample size, that is n. Question 21. The number of calls coming per minute into a hotel reservation center is Poisson random variable with mean 5. What is the probability that no calls come in a given 1 minute period? assume that the number of calls arriving in 2 different minutes is independent. What will be the probability that at least 2 calls will arrive in a given 2 minutes period? You have option A, e raised to minus 2, which is basically 0.9995, B, e raised to minus 5, which is 0.9995, C, e raised to minus 5, 0.9922, e raised to minus 2, 0.9922. Let us say, if I look at the solution, e raised to minus 2, 0.9995 in Poisson distribution probability is given as pk lambda raised to k into e raised to minus lambda divided by k factorial. So, you will have for x is equal to 0, the probability e raised to minus 5. If you look at, let x and x2 be the number of calls coming in the first and second minutes respectively. So, what we want, probability x1 plus x2 greater than or equal to 2. I can also write it as probability of x1 plus x2 is equal to greater than or equal to 2 is equal to 1 minus probability x1 plus x2 less than 2. So, if I apply the probability principle, then 1 minus probability of x1 is equal to 0 and x2 is equal to 0 plus probability x1 is equal to 1 and x2 is equal to 0 plus probability x1 is equal to 0 and x2 is equal to 1. These are the possibilities. 1 minus probability x1 is equal to 0 into probability x2 is equal to 0 plus probability x1 is equal to 1 into probability x2 is equal to 0 plus probability x1 is equal to 0 into probability x2 is equal to 1 can be the simplified version. Hence, 1 minus e raised to 5 minus 5 into e raised to minus 5 minus e raised to minus 5 and so on can be considered as the expression. This results in 1 minus 11 e raised to minus 10, which is 0.9995, and hence the correct answer is e raised to minus 2.995, which is B. Question 22. Which formula gives the probability in normal distribution? A, Px is equal to 1 upon square root of 2 pi sigma square into exponential minus x minus mu whole square divided by 2 sigma square. And similar way, you can see that the terms are rearranged in option B, C and D, and you are expected to tell the correct formula for the probability in normal distribution. The correct answer, normal Gaussian distribution is, correct answer is A, and it can be expressed as Px is equal to 1 upon square root of 2 pi sigma square into exponential minus x minus mu whole square divided by 2 sigma square. Question 23. While examining a normal distribution curve, 99.73% of the data falls between. Is it option A minus s to s, option B minus 2s to 2s, option C minus 3s to 3s, or option D minus 1.5s to 1.5s? You can see the correct answer is C. This is the property of the normal distribution curve, that 99.73% of the data falls between minus 3s to 3s region. You can further verify this using the standard normal distribution table and see that whether this probability matches with the given value in table or not. Question 24. Which distribution is used in market research? Normal distribution, chi-square distribution, t distribution, or it is Weibull distribution? The correct answer is B, which is chi-square distribution. You can see the logic. Market research generally uses this distribution because it can check independence, which has a greater importance in market research. The chi-square statistics is commonly used for testing relationship on categorical variables, and the null hypothesis is that no relationship exists on this categorical variable in the population, they are independent. Hence, chi-square statistic is most commonly used to evaluate the test of independence, and when specifically using a cross tabulation known as bivariate table. Cross tabulation presents the distribution of category variables simultaneously with the intersection of the categories of the variable appearing in the cells of the table. The last question in assignment 3 is question 25. Let X is equal to ultimate tensile strength expressed in PSI at minus 200 degree Fahrenheit of a type of steel that exhibits cold brittleness at low temperatures. Suppose X has a Weibull distribution with parameter beta is equal to 30 and theta is equal to 110. Find what is the probability of X less than or equal to 107, and second, what is the probability that X will fall within 95 and 105. You are given 4 options A, B, C, D. You can see it on the screen. The correct answer is B. Let us look at the solution. Probability X less than or equal to 107 can be given as, what is the cumulative probability? 107, 30 and 110. So, I can use the Weibull expression and substitute the values 1 minus e raised to minus 107, 110 raised to 30. This comes out to be 0.3535. Similar way, for second option, probability 95 less than or equal to X less than or equal to 105, I can subtract two cumulative distribution function f105, the parameters are 30 and 110 minus f 95, 30 and 110, and this gives me 0.2038. Thank you very much for listening to the solution of assignment 3, and I hope by the time you would have clarified your many doubts and you have digested the content given during the last 3 weeks in multiple lectures, and subsequently we will see the solution of assignment 4. Thank you very much once again and wish you all the best.